Okay, today we're going to look at transformations of parabolas. A transformation just means taking a parabolic function, that basic shape, and moving it around. And we've done a few things, so we're just going to look at a new one today, mainly that a value. If you increase that a value, you're going to get a much narrower parabola because you're going to start to increase much more quickly with a bigger number out there in front of your squared term. If you put a smaller coefficient in front of your a squared, it's going to flatten out and widen your parabola because you're going to increase much more slowly by multiplying by a fraction. The other thing we've worked on now in our labs for a couple days is changing our c value, and that's going to shift your parabola up and down. Okay? We are going to start with our parent function, which is just f of x equals x squared, and we're going to compare all of our graphs to that, unless it specifically says compare two different graphs. So let's take a look at our problems down below. Which is wider, g of x equals 4x squared or g of x equals 1/2 x squared? I say g of x equals 1/2 x squared is wider. Down below, how would you be able to tell without looking at their graphs? Well, I look at the coefficients of a out front and I compare their absolute values. So since the absolute value of 4 is greater than the absolute value of 1/2, then the smaller makes it wider. A little bit backwards thinking. Number 2, why would g of x equals 4x squared and h of x equals negative x squared have the same width? Let's compare their absolute values of the a. So the absolute value of 4 compared to the absolute value of negative 4, when you look at the absolute values, they're actually equal. And only that a coefficient determines width. So since the absolute value is the same, the width is the same. How would their graphs be different? Remember with that a value, if it's positive or if that a value is negative, one opens up, specifically g of x, and one opens down, h of x, since h of x has the negative a value. Number 3 says order the graphs of the following functions from narrowest to widest. Remember, I'm just looking at all these coefficients, at the absolute value of them. I'm going to go ahead and circle that negative because remember, for x squared to exist there has to be a 1 in front of it. So the absolute value of that negative 1 would be 1. So from narrowest to widest, narrowest is going to be the largest coefficient absolute value. 3 is my largest absolute value coefficient, so it's the narrowest. 2 has the next one. 1, and my fraction will be the widest. 4, which has its vertex below the x-axis? G of x equals x squared plus 5 or g of x equals x squared minus 7. So remember this c value, because I'm just paying attention to vertex, and this x squared is just my parent function. I've just shifted it or transformed it either up or down because my c value has changed. The plus 5 is going to shift my parabola up and actually above the x-axis, so there won't be any x-intercepts. So the vertex, in order to have x-intercepts also, is going to have to be below the x-axis, and negative 7 shifts it down, so this would be g of x. How would you be able to tell? The c value is negative. That's what shifts it down below the x-axis. And the last problem, how many vertical units separate the y-intercepts of g of x equals x squared plus 5 and g of x equals x squared minus 7? Okay, so we've taken this parent function of g of x equals x squared and we've shifted it up 5, and here's my g of x squared and I've shifted it down 7. So I can think of this, you know, here's my x-axis, my parent function, I've shifted it up 5, and the next one I've shifted down 7. What's the difference between positive 5 and negative 7? And notice I said different, so I could just subtract them, but I could just look on the number line or the y-axis and find how far it is from 5 to 7, and that is 12 units. So how would you be able to tell without looking at their graphs? Because I kind of just drew an example here. I can find the difference of their c values. So let's go ahead and do some graphing. Number 1 says to compare the graphs of the functions below, and it's given me space to graph them. F of x is my parent function. It goes through 0, 0. You guys will be able to graph this in your sleep soon. 2, 4. I could do 1, 2 also. 3, 9. And remember, I can just mirror that over here on the other side. Sorry, 1, 1. 2, 4. Messed that up, guys. Negative 3, 9. And I can sketch that in. You guys will get really good at drawing parabolas. The next one is 2 times x squared. Putting a coefficient in front of x squared that's a large number is going to make it narrower, so I'm going to increase much more quickly. So let's go ahead and look at how that happens. If I put in 1 for x, then I'm going to do 2 times 1 squared. It's 2. If I put in 2 for x, I do 2 times 2 squared. That's 2 times 4 is 8. If I put in 3 for x, 3 squared is 9 times 2 is 18. Do you see how much more quickly I start to grow? And that's going to make it grow so much more quickly. So now I'm at 1, 2. I'm at 2, 8. And at 3, I'm off the charts. So I'm just going to mirror those. Draw that in, skinny little bugger. And then I'm going to label them. This first one was f of x, and this inside one was g of x, so that I know. So on your graphs, when you're dealing with 2 parabolas, please label so you know which graph is which. And now down below, I'm going to compare them. So I'm going to say g of x is narrower. Okay, the axis of symmetry is same, the vertex is same. Gosh, everything about it is the same. All I've done is narrow it. So I'm just going to put in there the vertex is the same. Because if the vertex is the same, then the axis of symmetry must also be the same. Okay, so I'm going to let you guys do number 2. Pause it if you want to and complete that right now. We're going to move on. Number 3 says compare the graphs of g of x equals negative 2x squared minus 1 and f of x equals x squared. Well, that's really nice. They've already graphed them for us. So I can use my equations up above to help me with the comparisons, and I can also look here. It's a little hard to see about the narrowness. It does look like g of x is maybe a little bit more narrow. I know for sure that it is because the absolute value of negative 2 up above is less than my parent, or is greater than my parent function. So I'm going to say g of x is narrower. Okay. Well, they don't open the same way. I can say that g of x opens down, f of x opens up, and according to their equations, because this is negative, that makes sense, and this one's positive. The axis of symmetry is the same. It's the y-axis, and it's important to state that at this point. Axis of symmetry is the same. It's important because the vertex is different. And then since it is different, you should probably state the vertex of f of x is 0, 0, and the vertex of g of x, we've shifted it. We've shifted it down 1. So that vertex is going to be 0, negative 1. Okay, so with 4 and 5, we have to do the same thing that we just did with 3, except we're not given the graphs. We have to do the comparison with just the equation. So let's first look at the narrowness of it. My parent function, x squared, f of x equals x squared, and I'm comparing it to 1/4 x. Remember that 1/4 makes it grow so much more slowly, it opens it up, so g of x is wider. Okay, do they both open up or down? They both open up. So I'm actually not going to include that as a comparison because they're the same. Let's look at the axis of symmetry. The axis of symmetry is going to be the same. We're going to learn a little bit later. B is going to be our axis of symmetry changer. But I've shifted one of them. So my parent function's vertex is at 0, 0. But this vertex is different because I've changed the C value. So vertex different. I forgot, axis of symmetry same. So let's go ahead and define those vertexes. The vertex for g of x is going to be 0, comma, whatever it's been shifted, so plus 4. And the vertex of f of x is 0, 0. All right, you guys are on your own for 5. You'll have to get that checked with me tomorrow.